Welcome to another Friday Swift Code Challenge. Today I'm gonna show you the fast and slow pointer technique, also known as the tortoise and hare algorithm. Linked lists are commonly used data structures in Swift. A linked list is basically a chain of special elements called nodes. A node holds a value and one or two references depending on the type of the list. If we have a list with two references, it's called a doubly linked list. Doubly linked lists have references to both the next and the previous nodes. If we have a list with nodes that only have a reference to the next node, that's called a singly linked list or unidirectional list. In this challenge, your task is to write a function that takes a singly linked list as its input parameter and returns the node at the middle of the list. Consider the following linked list. The middle node in this list would be node 2. If the linked list has an even number of nodes, we'll return the node closer to the end of the list. So, for a list with 4 nodes, we'd return node 3, since it's one of the 2 middle nodes in the list and the one closer to the end. Note that linked lists are not built into the Swift standard library. Thus, we'll use a custom singly linked list implementation for this challenge. You can download the Starter Playground project from GitHub. I've included the link in the description. So here's the node class that we'll use to create our linked list. It's a generic class. Thus, it can hold any type of value. The node class has 2 generic properties, value and an optional next property. The next property holds the reference to the next node in the list. The linked list class relies on the node class to create a singly linked list. The first node is called the head, and the last node is called the tail. The class also has 2 corresponding computed properties, head and tail, for retrieving the first and last nodes in the list. Both head and tail are of type node and are optional, meaning they can be nil. Thus, an empty list will have both head and tail set to nil. Note that first and last are internal properties. I've only exposed the getters via the head and tail computed properties to avoid directly setting the first or the last node. We don't want that. We'll use the append method to add new nodes to the end of the list. The append method creates a new node first. Then it checks if the linked list is empty by looking at the tail node. If the list is not empty, the new node is appended to the end of the list by setting the current tail node's next property to point to the new node. On the other hand, if the list is empty, the first node is set to point to the new node. Finally, the last node is set to point to the new node in both cases. To create a new list, you simply invoke the initializer. At this point, the list is empty, and both head and tail are nil. We'll call the append method to add a few nodes. List append 1, list append 2, and list append 3. You can use the head and tail properties to access the corresponding nodes in the list. List.head.value should print 1, and list.tail.value should print the value of the last node, which is 3. And the next node in the linked list can be retrieved using the next property of a node. For instance, to get the second node in the list, I'll write list.head.next.value. Okay, that's enough background information. Time to write some code. As usual, I let you work on this challenge before I show you my solution. Use the playground file linked in the description as a starting point. Now press pause and code away. When you're ready, hit play and take a look at my solution. And we're back. How did you do? Now let's have a look at my solution. The easiest way to solve this problem is to use the fast and slow technique. I'll start by creating a linked list extension to demonstrate a useful feature of the Swift language that lets us extend existing types without modifying their source code. Then I'll create a computed property called middle. It's a generic property of type node, and I'll make it optional in case the list is empty. This property should be read-only. I can specify that by providing only the getter. First, I'll check if the list is empty. If it is, I'll return nil. I'll set up two variables called slowPointer and fastPointer, and initialize both to point to the head of the linked list. Then I'll write a while loop that will run until the fastPointer or its next node reaches the end of the list. You'll understand why we need the next node check in just a moment. Now, here comes the clever part. Inside the while loop, I advance the slowPointer by one node and the fastPointer by two nodes at a time. That's why this technique is called fast and slow. I'll keep moving the pointers through the list as long as the fastPointer and the fastPointer's next property is a nil. When the fastPointer reaches the end of the list, the slowPointer is at the middle of the list, because it moved through the list at half the speed of the fastPointer. The following animation shows how this works. Now that I have the node at the middle of the list, I can return it. And that's pretty much it. All that's left to do is test our code to make sure it works. So let's print the value of the middle node in our sample list. If it's nil, I'll print list is empty. Prints 2. Okay, how about an even numbered list? I'll append another node to our list with a value of 4. List.append 4. The result should be 3. And prints 3. Great! I hope you enjoyed this challenge and that you learned something new. Don't forget to like and subscribe if you want to see more Swift code challenges like this in the future. And if you want to delve a bit deeper into the Swift programming language, then check out my course on data structures and algorithms in Swift. It's available using the link in the description below. Thanks for watching, and I'll see you next time.